Okay, this is concept 36 continued. This is proving parallelograms in the coordinate plane, and when we say coordinate plane, we're talking about the Cartesian plane, right? When you have the x and y, and you're going to have to visualize, for all these problems we're going to be doing here, we're going to have to visualize the parallelogram in the coordinate plane. Okay, and the purpose of this second part of concept 36 is to prove that given points you have a parallelogram. How do you know that it's a parallelogram? So there's three methods to proving that you have one. For the first one, you prove both pairs of opposite sides are congruent if AB, okay, and I'm using this figure here, AB is congruent to CD because they are opposite sides. So AB is congruent. If you recall this symbol, the equal with the squiggly line on top means congruent to CD, and DA, the other pair of congruent sides, is DA to CB, BC, sorry. So DA is congruent to BC. Then ABCD is a parallelogram. So how do you prove using that opposite sides are congruent in the coordinate plane? You would use the distance formula. And if you recall, we can actually write it in here. The distance formula is D is equal to the square root, and it's a long square root, the difference of the axis, so x2 minus x1 squared plus y2 minus y1 squared. Okay, and x2, x1, y2, y1, those are the when you label the coordinate pairs wherever they're given. Method 2, you would prove both pairs of opposite sides are parallel. Okay, if AB and CD are parallel. So AB is parallel to CD, and if you recall, okay, this double line here means that the two segments are parallel. AB here is parallel to CD; they don't intersect. And AD is parallel to CB. That's the other set of parallel sides. So how would you use, taking the idea that the pair of sides are parallel? Okay, you would use the slope formula for method 2 to show that proof. And then if you recall, the slope formula is m is equal to y2 minus y1 over x2 minus x1. That's slope. For method 3, you have prove one pair of opposite sides are congruent and parallel, so you use both. You would take one side, you can use top and bottom, so AB is congruent to CD, so AB is congruent to CD, and then you take the other set, or you can show that the same sides that you took, so AB is equal to CD, and you would also show that the slope of both lines of both segments is also the same, so AB is also parallel to CD. So again, in addition to showing that they're equal in length of value, okay, you're also showing that they are also parallel by slope. This is CD. Okay, and then for that you would use both. You use distance formula and slope formula. So for our first example, it says determine whether the figure is a parallelogram using the distance formula. So again, the idea is that between each set of vertices here that you're going to be taking based on the points, the distance between each one needs to show that the sides are congruent, that the opposite sides are congruent. So first thing you want to do is just draw out the arbitrary parallelogram. So you're going to have something like this. Okay, that's my parallelogram, and you can label your sides. We have A, B, C, and D, and the opposite sides are congruent. AB to DC, AD to BC. So take the distance formula. So AB, if you recall, the distance formula is a method of measuring length or distance, right? So for AB, here's A, here's B. Okay, so I'm going to plug into the distance formula here. Okay, I don't want to label my points because I'm going to be relabeling as I plug in all the points. So just keep track of which ones you're taking. So for the first one, I have x2, so 1 minus x1. So here's x1, negative 7, because I'm subtracting, it becomes plus 7 squared, plus, and then y2 is 2 minus 4 squared. I get, I'm showing all my steps here, so 1 plus 7 is 8 squared, plus, and then 2, let's put this in parentheses, 2 minus 4 is negative 2 squared. Okay, so then I get 64 plus positive 4, and I get the square root of 68. I don't have to simplify this. I can go ahead and leave it that way for now. All I'm going to be checking at the end is that hopefully the opposite side is the same. So I just took AB. Let's take DC now. DC, and let's go ahead and go clockwise. So I took A to B. Let's take C to D. Okay, that way it keeps keeping track here. It makes it easier. So I have CD next. Okay, there's my square root. I have x2, so 1 minus 9. That's x2 minus x1 squared, plus, then I have y2, negative 6, minus negative 8, minus negative 8, it becomes plus 8, so plus 8 squared. That's equal to, and I get 1 minus 9, I get negative 8 squared, I get 64. Negative 6 plus 8, I get 2, and then 2 squared is 4. And this is equal to square root of 68. So the two opposite sides, AB and DC, are equal. So let me use red. We just shown those pairs of opposite sides are equal, so we're good there. Now let's show AD and BC are equal. So AD, here's A, here's D. X2 in this case is 1, and I'm going to subtract 7, negative 7. Subtract negative 7, it becomes plus 7. So 1 plus 7. So I get 1 plus 7 squared. And then I have negative 6 minus 4. So plus negative 6 minus 4 squared. 1 plus 7 is 8. 8 squared is 64. Negative 6 minus 4. Negative 6 minus 4 is negative 10. Negative 10 squared is 100. So plus 100. And this gives me square root of 164. Next one, so that's AD. I'm going to take BC. So BC, the two center points here. And I have x2, 9 minus 1 squared, plus, then I have negative 8 minus 2. squared. 9 minus 1 is 8. 8 squared is 64. Negative 8 minus 2 is negative 10. Negative 10 squared is positive 100. And then 100 plus 64 is square root of 164. So then we showed now that AD is congruent to BC. So they all, pair of opposite sides are congruent. Okay, so we just showed that, yes, ABC D is a parallelogram because the opposite sides are congruent. Number two would be the exact same idea, and let's go ahead and draw out. Remember, the first thing you want to do is just draw out the arbitrary parallelogram, what you're dealing with. Okay, and remember, you're visualizing these in the coordinate plane. This time we have PQ RS. Okay, and then let's take PQ and RS. So PQ, we find the length. PQ are the first 2 points here. So I have x2, 6 minus negative 4. Minus negative becomes positive, so 6 plus 4. 6 plus 4 squared plus y2, 4 minus 2 squared. So 6 plus 4 is 10. I get 10 squared. 4 minus 2 is 2. 2 squared, I get 4. So plus 4. Well, I should say 2 squared. I'll show every step here. 2 squared, so I get 100. 100 plus 4, and then that gives me square root of 104. So then PQ, the measure of PQ is square root of 104. Again, you don't have to simplify. And then finally, let's do RS here. Okay, we need to show that these two are equal, because we should have, if it's a parallelogram, we should have that. Okay, so let's do RS next. RS are these 2 points here. So y2, negative 3. Negative 3 minus negative 2. So I already have a negative minus, so it becomes positive. Plus 2 squared plus 2 minus 11. Yeah, 2 minus 11 squared. So I should have no here so that there's no confusion. If you go to my distance formula, I think there might have been some confusion over which ones I'm taking first, the x's or the y's. It actually does not matter. So you can take the x's subtracted first or the y's subtracted first. So I apologize if there was any confusion regarding how I was plugging them in here. Okay, continuing here. Negative 3 plus 2 is negative 1. Negative 1 squared is positive 1. 2 minus 11, I get negative 9. Negative 9 squared is 81. Square root of 1 plus 81 is square root of 82. So we jump into a problem here now, okay? PQ is square root of 104, and then in properties of parallelograms they tell us that the opposite sides need to be equal, and we just showed that RS or SR is square root of 82. These should be equal if you have a parallelogram, and they're not. Okay, they are not equal. So in this case, no. PQRS is not a parallelogram. And you're done. Okay, you just proved that these set of points here do not create or make up a parallelogram. Moving to the next one, make sure you read the directions carefully so that you use the correct method that they're asking for to show or prove that you have a parallelogram. This one, or the next two questions, ask us to use the slope formula. Okay, so this is method 2. Okay, you're showing that the two sides, right here, sorry, method 2, you're showing that the pairs of sides, okay, the pairs of sides are parallel using the slope formula. So if this was in the coordinate plane, okay, you would have to show that each pair of sides here, okay, has the same slope, the rise over run from D to A. So this rise here, okay, is the same one as this one here, okay, and similarly for the other two sides. That would show that you have parallel sides. So with number 3, and then again, last little note here, to denote slope we use M. Okay, so when I have this notation, so M of, we'll take WX, okay, WX segment, we're talking about the slope of WX. So let's draw that parallelogram here, and again, this is the arbitrary one. Okay, and I have W, X, Y, Z. It goes clockwise, and then we're going to show that the sides are parallel. So similarly to before, you're just going to keep track of what your Y's and your X's are between 2 points, and then plug in carefully to the slope formula. Okay, I have y2 minus y1 in the numerator, so this first one is wx, this point and this point. So here is w2, negative 6 minus negative 4. Okay, so minus negative becomes positive, so I have negative 6 plus 4 over the x's. 1 minus 7, and again 1 minus negative, it becomes positive, so 1 plus 7. And I get negative 6 plus 4, that's negative 2. Negative 2, 1 plus 7 is 8. And I can simplify negative 2 over 8 into negative 1 over 4. So that's the slope of WX. Let's take ZY next, because again, if they're parallel, the opposite sides need to have the same slope. So measure of, we have YZ, again that's the opposite side, okay. YZ is these 2 points here, okay. So the Y's, subtract the Y's, negative 12 minus 13, and then it's minus negative 12 minus negative 13, so it becomes positive, over the x's, 1 minus 5. And then negative 12 plus 13, you get 1, right? You owe 12, you pay off 13, you still get left with 1. 1 minus 5, you get negative 4. And then you can see that the measure of the slope of the opposite sides, WX and ZY, is the same. Okay, so those two sides are parallel. Moving on to the other, we have to check these as well. Okay, we need to check that these are also parallel using the slope formula. So showing the next one would be XY. So XY is this side, we need to find the slope. Okay, XY is the two center points. The two center points here, so subtract my Y is negative 13 minus negative 6, it becomes positive because of the negative. So negative 13 plus 6, and then 5 minus 1. And then I get negative 13 plus 6, I get negative 7. 5 minus 1, I get 4. And I can't simplify that fraction further, so I leave it like that. Now we need to check that this side, WZ, gives me the same slope. So the measure of WZ is the y's. Where's WZ? So here's W, there's Z. So I have -4 minus, or sorry, -12 minus -4. Minus, so -12 minus -4, this becomes positive, over 1 minus -7, so it becomes 1 plus 7. -12 plus 4 is -8. 1 plus 7 is 8, and then -8 over 8, that simplifies to -1. So then you see that these two slopes here are not the same. Okay, they need to be the same. So therefore here we have, and then you guys remember my 3 dots, right? That means therefore not a parallelogram. And you're done. You just proved using slope that these points here do not make up a parallelogram. Number 4, same same idea here. We're going to use slope to figure out if we do have a parallelogram. So here's my arbitrary parallelogram, and we're using EFGH. So here's EFGH, and let's take the measure of the slope of EF first and the measure of the slope of HG first. So measure of EF, I have 10 minus 8 over 6 minus 0, so I get 2 over 6, and that simplifies to 1/3. Then I have the measure of HG, and then the order of how you plug in which one you consider Y2 and X2 does not matter, so as long as you're consistent. So if this is my Y2, this is also my X2. Okay, in case I haven't been using the same order. So Y2 -2 minus 0, -4 minus 2, -2 minus 0 is just -2, -4 minus 2, you owe $4, you owe 2 more, you owe a total of 6, -2 over -6, negative over negative becomes positive, and then 2 over 6 simplifies to 1/3. So we just shown that the slope of the opposite sides here is the same. So we're good here. Let's check now EH and FG. So the measure of EH, or the slope of EH, is E, there's H, so -2 minus 8 over -4 minus 0. -2 minus 8, you owe 2, you owe 8 more, you owe a total of 10. -4 minus 0, that's -4. Negative over negative is positive, and then you can simplify 10 over 4 into 5 over 2, so positive 5 over 2. Finally, we have the measure of FG. There's F, there's F and G, so I can do, and again, it doesn't matter, so as long as you stay consistent. So we'll do 0 minus 10, that's Y2, that's Y1, and then 2 minus 6. So I get -10, because 0 minus 10 is -10. 2 minus 6, I get -4, and then that's similar to the top one, so we know it's going to simplify the same. And so the slope is also the same. So we do have a pair of opposite sides with the same slope. So therefore, yes. Okay, EFGH is a parallelogram. And we're done. Moving on to 5 and 6. 5 and 6 say, determine whether the figure is a parallelogram using the distance and slope formulas. So what you do here, okay, all you have to do is just pick one pair of opposite sides and then just check to see if they are the same length using the distance formula, and then check if they're parallel using the slope formula. So first thing, right, is draw out our parallelogram, and we're talking J, K, L, M. So we got to show that JK is the same length as ML. So the distance, so JK, we use the distance formula. There's J, there's K, so I have my Y subtracted 1 minus -2, so it becomes 1 plus 2 squared plus -5 minus -9, so it becomes -5 plus 9 squared. 1 plus 2 is 3, 3 squared is 9, -5 plus 9, that's positive 4, 4 squared is 16, and this gives me square root of 25. And then this one we do simplify, we know because it's a perfect square, square root of 25 is just 5. So now we need to check that ML is also 5. So ML, we use the distance formula, there's M and L, and then Y2, let's just call this one Y2, Y1, so -7 minus -4, and then minus negative becomes plus 4 squared plus -3 minus 1 squared. -7 plus 4 is 3, 3 squared. -7 plus 4 is -3, -3 squared is positive 9, -3 minus 1 is -4, -4 squared is 16. And then yeah, it does match up with the top, square root of 25, and that's 5. So we know, we have for sure that JK is congruent to ML. Now we need to check to see if they are parallel, and we use the slope formula. So M, the slope of JK is Y2 minus Y1, so 1 minus -2 becomes 1 plus 2 over -5 minus -9, or -5 plus 9. You get 3 over 4, and then we can't simplify further. So let's check the slope now of LM. There's LM, -7 minus -4, so it becomes -7 plus 4, -3 minus 1. So -7 plus 4 is -3. -3 minus 1, you owe 3, you owe 1 more, you owe a total of 4. You have a negative over a negative, so it becomes positive. And yeah, these do have the same slope. So they are congruent and they are parallel, and then that's enough already to show me that this is a parallelogram. So we have JKLM is a parallelogram. Okay, so again, just please follow the directions using the method that they ask you for. Okay, don't just jump into this one for all problems. Okay, stick to what the directions are asking. Finally, last one here, same idea. Let's draw out a parallelogram. We have S, T, U, V. Let's check, let's just pick top and bottom. Let's check that ST is equal to VU. So we use the distance formula. ST So 7 minus 5 squared plus 10 minus 1 squared. 7 minus 5 is 2, 2 squared is 4, 10 minus 1 is 9, 9 squared is 81, and this gives me square root of 85. And we can stop there. Then we take UV. Let's check to make sure it's also square root of 85. So I have negative 1 minus 1 squared plus negative 3 minus 14 squared, and then I get negative 1 minus 1, that's negative 2. Negative 2 squared is 4. Negative 3 minus 14, that's negative 17. Negative 17 squared, you can use your calculator for that. You're going to get 289 plus 289. And this is square root of 293, and those are clearly not the same. And you can stop right there, because that means that those two are not congruent. So therefore, no, STUV is not a parallelogram. Okay, and that wraps up concept 36.